Okay, this here is a review of what we learned about logarithms so far. Evaluating, expanding, condensing, solving some logarithmic type equations, all that good stuff. Okay, a little bit of everything. Everything we do, you have to be able to do with a 4-function calculator. No TI-30XS multi-view. So good luck with that. If you have a pencil in your hand right now, put it down. You must watch the video, learn what you need to learn, and then go back and see if you can do it yourself. You will not learn by copying me. Okay. This is the tenths place, the hundredths place, the thousandths place. That means this is the same as log of 1 over 1,000. Okay, we need to evaluate this. Now, 1,000 is 10 to the third power. You might have guessed that by the fact that it has 3 zeros. Alright, 10 to the third power has 3 zeros, 10 to the fourth power has 4 zeros, and so on. So that means this is just like having log of 1 over 10 to the third power. Now, it would be more convenient for me if I wrote it this way. This would be the same thing as log of 10 to the negative 3 power. Because of the way it's dropped down to the denominator, that's what would happen if I had a negative power. Okay, this is going to work for me better. Now, when I just have log without a base showing, like on this one with a little 4, base 4, when there's no base showing on a log, L-O-G, you know it's an invisible base 10. That means we are asking ourselves the question, 10 to the what power is equal to 10 to the negative 3 power? Okay, so obviously the question mark is negative 3. So that is the answer to this question. Negative 3. Kabam. Alright, moving on. I mean, as a shortcut, you know, when you have log base 10 and base 10, they cancel out. But this is how you show your work. Alright, looking at number 2. Alright, you know, I mean, if you use the shortcut, log base 2, you know, the answer is going to be 8. But the way you show your work, though, the proper way, is by showing that you know that we ask ourselves the question 2 to the what power is equal to 2 to the 8th power. Alright, it's always base to what power makes the rest of it. And you see that the question mark is 8. Bam, bam. Now on this one, we ask ourselves 5 to the what power is equal to 1. Well, that question mark can only be 0. Anything to the 0 power is 1. Okay, we are on fire. We cannot be stopped. Okay, take a look at this. Well, I mean, you know what? Are we allowed to, you know, expand and condense and that kind of thing? I feel like condensing this. Alright, let's do that. This is a sum. And we know good and well that if we have a sum like this, we can condense it down to multiplication. Okay, so one way to do this problem would be to go, alright, this is going to condense to multiplication. So this would be like log base 4 of, you know, 2 times 32. Okay, so that's log base 4 of 64. Okay, So that means we're asking ourselves the question, 4 to the what power makes 64? Now I know that's 3, alright, because I'm the man. Let's move on to number 5. Okay, this is the tenths place. So once again, this would be like having log base 5 of 2/10. Now this will reduce. So this will be log base 5 of 1/5. Liking those 5s there. That 5 in the denominator, alright, so that would be the same thing as having log base 5 of 5 to the negative 1 power. Okay, now these logs, log base 5 and base 5, they're going to cancel out and give us negative 1. Alright, but you got to show your work. Alright, we know the answer is going to be negative 1. But the way you show it is by showing the question. 5 to the what power is equal to 5 to the negative 1 power. Boom, boom. And obviously the question mark is negative 1. That's how you show your work. Do it. But Mr. Burton, why can't we just do it? Stop crying. Alright, number 6. Do you remember what I taught you about cube root? I'm hoping you remember that the cube root of x is the same thing as x to the 1/3 power. Okay? So the cube root of 6 is the same thing as having 6 to the 1/3 power. So once again, bam, bam, this is going to be 1/3. Okay, if only we were allowed to just show it that way. Why does it always jump when it does that? But we will show our work properly like this. 6 to what power is equal to 6 to the 1/3 power? Obviously the answer will be 1/3. Question mark is 1/3. Okay, it just takes an extra second. So we're going to show our work properly. Okay, what's going to be the easiest way to do this? I'm seeing so many different ways now. I'm just going to do it straight the way it is. So if I've got negative 2 log base 4 of this thing. See how it's in the denominator? I know you do. So that's the same thing as 256 to the negative 1 power. Okay, so you know what I'd love to do with this right now? I have to show you this 2 different ways so you can decide which way you like best. I like using these properties, you know, like on this problem up here where we went ahead and condensed before we evaluated. You know, that was genius. First thing I see here, because I've been doing a lot of you know, expanding and condensing, is I could use the power rule right now. That was the one that says when you have an exponent, you know, a log of something with an exponent, you can put it in the front. So you know, I feel like it would benefit me right now if I took that negative 1 and bloop, put it out front. So I'm going to do that. I'm going to take this negative 1 and put it out here. Now please understand, if I do that, then I'm going to have negative 1 times negative 2. That's going to make this a positive 2. So all that's going to happen is I'm going to have a positive 2 log base 4, and now I've just got the 256. Alright, see, that just, I like it. No negative 1, no negative on the 2. Simple. Now I can go back to asking myself 4 to what power makes 256. You know what I'm saying? I'm looking at this and I know it means this. 4 to what power equals 256. Table, right? 4, 256, that's the 4th power. Okay, so 4 to the 4th power. So that means the answer to this question right here is 4. Right? 4 to the 4th power. So that means right here I've got 2 times 4, which is 8. So, alright, that's where that came from. Anyway, boom. So that's the answer to the question. So, that was one way to do it. That was my favorite way to do it. Here's another way to do it. Okay, so I've got -2 log base 4. Alright, I could do it this way. Instead of making this 256 to the -1 power, I could go ahead and figure out what 256 is in this form. And as we saw, 256 is 4 to the 4th power. So that makes this 1 over 4 to the 4th power. Okay, now I can bring in the negative exponent. So that would make this -2 log base 4 of 4 to the -4 power. Okay, so that shortcut we're always trying to use. Log base 4, base 4, those are going to neutralize each other. Off to the side, let's show our work, because we ask ourselves the question, 4 to the what power? I'm talking about that base. 4 to the what power will give us this, which is 4 to the -4 power. Clearly that question mark is -4. Okay, so that's what's happening here. Okay, but anyway, so that's going to give us -2 times -4, once these cancel out. And that's why the answer is 8. So that's another way to do it. Alright, let's move on to number 8. Alright, I'm definitely going to condense these. So looking at our properties, I see subtraction, quotient property, A over C. Okay, so that makes this log base 2 of 6 over 48. Okay, this reduces, so this will be log base 2 of 1 over 8. Alright, I just divided them both by 6. Alright. Now, this is going to be the same thing as, 2 is 2 to the 3rd power gives you 8. So this is looking real good. Do you remember when I used to tell you when you have 1 over something like this, one way to think about it is go ahead and ask yourself 2 to the what power makes 8. Okay, so that would be 3, right? But since it actually is 1 over 8, then that means it's going to be -3. So that's going to be your answer. That's the quickest way to do it. Also, you could look at it this way. Log base 2 of 1 over 8. Okay, that's log base 2 of, now 8 is, like I said, 2 to the 3rd power. Alright, so that's log base 2 of 2 to the -3 power. And then bam, bam, it's -3. There's just so many ways to do these things, it's crazy. But either way, you're going to get -3. Okay, looking at this one. Remember, the 4th root is the same thing as a 1/4 power. So, wait a minute. Stop, collaborate, and listen. I was about to do that the long way. The 4th root of 81. We can just get that right off the table, my friends. The 4th root of 81 is 3. So, the simplest thing to do for this problem would be to go, okay, this is log base 3 of 3. Alright, clearly that answer is going to be 1 because we asked ourselves. We said self 3 to the what power will give me 3. Bam, kabam. And that would have to be a 1. So that's why it was 1. Okay, number 10. Alright, expand each expression. Simplify all answers. Beautiful. Alright, so we're expanding. Clearly this is the product rule. Alright, this will expand as addition. Log A plus log C. So in this case, that's going to be log 8 plus log x. Alright, that's all there is to that. It's simple. Alright, this one. First thing, please remember, square root of z is the same thing as z to the 1/2 power. So this would be the same thing as log base 3 of x, y, z to the 1/2 power. Okay, now we are going to use our product rule, only there will be 3 things being added. A plus C plus D, if you will. Okay, so that's going to give us log base 3 of x plus log base 3 of y plus log base 3 of z to the 1/2 power. And now using the power rule, this c is going to come in front like this. So the 1/2 is just going to jump to the front of the bus. Alright, Rosa Parks up in here. So this is going to be log base 3 of x plus log base 3 of y plus 1/2 log base 3 of z. And that's your final answer. What? Alright, number 12. Okay, it's all about the quotient rule. My friends, log a over c equals log a minus log c. Yeah, we're expanding, so that's awesome. So we're going to do log base 8 of 2xy, alright, that's the a part, minus log base 8 of z, that's the c part, the a and the c. Now, this part right here will have to be expanded further. I think I'll just use purple. Because this part has a product in it. You know what? My friend Mr. Allen told me not to do this in separate steps. See, I was about to do this. I did this step first with the quotient rule, and then I was going to split this up, you know, with the log 8 2 plus log base 8 of x plus the log base 8 of y, and then I was going to tack on the minus log base 8 of z, and I'm still not done. But Mr. Allen was telling me yesterday not to show this step. He would say, look guys, you look at this problem and you see 4 things. Okay, we've got the 2, the x, and the y all in the numerator. Everything in the numerator, that's going to be addition. You know, it's going to be positive. And then we've got this thing in the denominator. Everything in the denominator is going to be subtracted. So everything in the numerator gets added, everything in the denominator gets subtracted. So 2xy, that's log 2 plus log x plus log y, and then minus log z. Brit, all in one shot. No need to do it in steps. So, you know, I try to learn every day from people. Somebody tells me something that I hadn't thought of before. So let's do it that way. See how it works for us. But did you notice that we're not done though? One of these four terms can be simplified more. Yeah, it's this one. Okay, because base 8 can become a 2. Alright, do you understand that 8 and 2? Square root? No. Cube root? Yes. So the cube root of 8 is 2. Alright, that means 8, if I ask myself 8 to the what power equals 2, because that's what you do. Base to the what power equals the other thing. So 8 to the what power equals 2? Well, that's 1/3 because it's cube root. So 8 to the 1/3 power equals 2. So that means the value of this is actually 1/3. Okay, and then you have the rest of it. So I'm just going to copy it down. So that would actually be your final answer, full credit. If you leave it log base 8 of 2, you're going to lose a chunk of points. So I don't recommend it. Alright, let's use the Mr. Allen method for this. Everything in the numerator is going to be positive, and everything in the denominator is going to be negative when we split this thing up using a combination of the product property and the quotient property, but shotgun. So that would make natural log x, right, the numerator, positive. These two will be negative. So minus natural log y minus natural log z. If you look at it that way, we don't have to worry about parentheses and all that. It's just automatic. Alright. Thank you, Mr. Allen. You're a genius. Now I'm a genius. Okay, number 14. This entire thing is square root. So that means it's like this entire thing is being raised to the 1/2 power. Okay, well that's the same thing as having a log of 3 to the 1/2 power, x to the 1/2 power. You know, I could just put that, I'll just keep going. 3 to the 1/2 power, x to the 1/2 power, and y to the 1/2 power. Alright, you can just do this power to each of these things. So now using the product property, where multiplication becomes addition, then this thing is going to become log 3 to the 1/2 power plus log x to the 1/2 power plus log y to the 1/2 power. Now using the power property, these exponents are going to jump to the front like c. So the final answer will be 1/2 log 3 plus 1/2 log x plus 1/2 log y. Alright, full credit. Number 15. Okay, so this is the same thing as log base 5 of x to the 1/2 power over y. Okay, so straight quotient rule. So this is going to be log base 5 of x to the 1/2 power minus log base 5 of y. Now when you're expanding, these powers go in the front, so I'm going to wind up having 1/2 log base 5 of x minus log base 5 of y. By the way, when you're making these bases, like these little 5s, you got to make them small and low. Alright, if I see you doing this, alright, log 5x, you know, big old 5, I'm going to have to take off points for this. Because this looks like you've got an invisible base 10 happening. You have to make it obvious that that base is a small little guy hanging down low, you know. The log and the x are on the same line, but the 5, or you know what, here's what kids do, students will do a lot of times. They'll put that 5 up here, and they'll treat this x like it's an exponent. So they'll do log 5 like to the x power. I'm definitely taking off points for that if you do that. Alright, that x goes right down here on the same line as the log, and the base hangs low. It's not an exponent. Okay, I digress, but it was important. I hope you stayed awake for it. Alright, you know what? It is midnight. It is 12:05 a.m. on, well, I guess technically it's Sunday morning, but it feels like Saturday night. Here I am making homework videos. Alright, so when I tell you all I do is math, I'm actually not joking. It's quite sad. Okay, so edit. I initially skipped number 16. I'm not going to try to play it off. So I finished the entire sheet, but then now I have to go back and do number 16. Okay, actually I skipped number 16 and 27, so I'm going to have to go back and do both of those. So thus a little weird edit right here. Anyway, the fourth root of stuff is the same thing as the 1/4 power. Okay, and you know this, man. So I'm going to do that. So this is going to give me the natural log of 3 over x to the 1/4 power, y to the 1/4 power. Now, I'm going to use a combination of the product property and the quotient property to expand this. Now, anything in the numerator is going to become a positive term. Anything in the denominator will become a negative term. Okay, so that's why I will have the natural log of 3, alright, positive term, numerator, minus natural log of x to the 1/4 power, alright, minus because it's in the denominator, and minus natural log of y to the 1/4 power. Okay, numerator, denominator, denominator, positive, negative, negative. Now all I have to do is take these exponents and drop them in the front, and I'm done. So this is going to be natural log of 3 minus 1/4 natural log x minus 1/4 natural log y. So that will be the final answer for number 16. So looking at number 17, I'm going to take this little power. Should I put it in front? Then I'll have to distribute. I'm just going to do the power to everything inside. That's my favorite thing to do. So that 3 is going to go bam, 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 and bam. So this would be like, I'll do it over here. So this would be like having log of, well, 3 to the 3rd power is 27. So 27. And then I'll have x to the 3rd power, y to the 3rd power, and z to the 6th power, because 2 times 3. Okay, so that just happened. So this is straight product property. 1, 2, 3, 4 logs coming up. So this would be like having log 27 plus log x at 3rd power plus log y to 3rd power plus log z to the 6th power. Now all of these powers need to end up in the front. I think I'm going to do that off camera because this is getting mad boring. So there you go. I just put all these exponents in the front. Bam, bam, bam. And this would be your final answer. Soak it in. And then move on. Okay, so here we go on this one. Again, I like to go ahead and apply the power to everything, kind of get rid of these parentheses before I do anything. So that would make this log base 2 of x to the 4th power y to the 4th power over z squared. Now, using the Allen method, everything in the numerator here is going to be positive when I expand it. Anything in the denominator is going to be negative. So that's going to leave me with log base 2 of x to the 4th power, positive, plus, alright, log base 2 of y to the 4th power, and then minus log base 2 of z squared. Okay, so using the Allen method, we do that all in one shot. Any factors in the numerator will be positive, like these two, and any factors in the denominator will be negative, like this one. That's the best way to do it. Now I'm just going to put each of these in the front, each of these exponents, but I will do that off camera. Kabam! So this is your final answer. Soak it in. You're welcome. Alright, number 19. Whoa! How many problems have I skipped? Please tell me that was the only one. Apparently I skipped number 16. I think I will go back and edit that in later. In fact, you won't even know I skipped it because I will have edited it already. Moving on. Alright, condense each expression, simplify all answers. So we're condensing now. So we're going in the other direction. So we're going to take things that are all split apart and collect it all into multiplication and division. And if we see any coefficients in front, bam, they're going to become exponents. Watch it. Watch me work. So let's clean up all these coefficients. So everywhere I see this coefficient, it's going to jump over and become a power. Now be careful because this 2 is going to have to become a power on, both of these things, the 8 and the x. So I can just see a kid just putting squared over here, and that's just putting it on the x. You got to get the 8. Got to get them both. Are you listening to me? Wake up. So this would become log base 5. Look, 8 to the 2nd power, 8 squared is 64. So that just happened. So then x squared. I had to square them both. Okay, and then this is still plus for right now. Log base 5 of x to the 3rd power. Okay, so using the product rule, I will put these together and I will multiply them. So that's going to be log base 5 of 64 x to the 5th power. Alright, because x squared times x to the 3rd power is x to the 5th power. Yeah. Anyway, that's it. That's the answer. Okay, yeah, that's genius. Alright, let's move on. Number 20. Alright, again, any coefficients are going to jump up and bite ya. Okay, and including this 1/2. Alright, so this 1/2 is going to come over here like so. Alright, so this is going to become, on the next move, it's going to be log base 4 of 9. Alright, because it's 3 squared once this comes over here. Should I show it as like a little 2? And this is going to become a little 1/2. Yeah, maybe I'll show that. Yeah, so meanwhile, this is going to be minus log base 4 of. Now remember, if I do the 1/2 power on this thing, that's the same thing as square root. So let's go ahead and do that now. So I have the square root of x squared plus 1. No, you cannot take the square root of these things separately. Alright, you just have to leave it on there like that. Just live with it, deal with it. Now we would do the quotient rule and turn this into a over c. We're going from this to this, a over c. Okay, so this is going to be, I'm going to put it over here, log base 4 of 9 over the square root of x squared plus 1. Alright, make sure you only write the word log once. Don't do log over log. It's just one log. Okay, on to number 21. Okay, so this is going to come over and become x to the third power. This is going to come over and become y squared. This is going to come over and become z to the fourth power. So that's great. Great, great, great. I'm going to copy this off camera. Okay, so you would have this once you did that. Now, I'm going to combine these using a combination of the quotient rule and the the quotient rule and the product property. But I'm going to do it Mr. Allen style. And the way Mr. Allen does it, anything that's any term that's positive is going to end up in the numerator. So, for example, this term right here is going to end up in the numerator. Now, any term that is negative is going to end up in the denominator. Alright, so these terms right here, so I'm going to have one term in the numerator and then 2 in the denominator. Okay, and of course we're condensing, so we're only going to have the word log once, log base 7. But then when we have our fraction, this is what I'm talking about. This green one is going to be in the numerator because it's positive. So I'll have my x to the third power. These two purple ones will show up in the denominator. You can tell because they're negative. So I'm going to have y squared and z to the fourth power down there. And that's it. Okay, so just do it in 2 steps. In one step, put the exponents where they belong. In the next step, collect it all. That's it. Thank Mr. Allen next time you see him. Alright, number 22 is kind of a special problem because we have to deal with this 3 sitting here in our faces, mocking us. Now, this 1/2 is going to come over and become a power, you know, so that's great. But what about this 3? Well, first of all, because see, we needed to have a log on it to be able to condense. We can't just have a number. It needs to be like log. This needs to be a log expression. So this is how I'm going to do it. You can imagine there's an invisible 1 right here. Now, I can replace a 1 with a log easily. Because remember this, like if I had log of base 2 of 2, what would be the answer to that? You know it would be 1. Now I'm mentioning log base 2 because that's the log that we already have is base 2. So since this is equal to 1, if I want to turn this into a log expression, all I have to do is take my invisible 1 and replace it with log base 2 of 2. Because I don't need parentheses at this point. So I can just write in, I can just stick on a log base 2 of 2. Now I can do that without changing the value because it's really just multiplying by 1. It's all good. Okay, but just like I took this 1/2 and put it up here, I can take this 3 and put it over here as a power. Okay, so this is going to be wind up, 2 to the third power is 8. So that's genius. So on my next step, I'm going to have log base 2 of. Now remember, this is square root, so I'm just going to have the square root of x squared plus 1. No, I cannot take the square root of each of these separately or anything like that. Meanwhile, I'm going to have minus log base 2 of 8. Okay, 2 to the third power. Now I'm ready for the quotient rule. So this is going to be log base 2 of numerator denominator. So this will be square root of x squared plus 1 over 8. And that would be the final answer. Okay, that was a little tricky because that was a new trick that we hadn't done in class before. So I hope that you are watching this video. If you're not watching this video, then I'm just talking to myself, and that just makes me a crazy person. Okay, let's see, 23, 24. Are we still, I guess we're still condensing. So let's keep doing that. So, continuing the same process. So this 2 is going to come over and square that. This 5 is going to come over, but, understand it has to show up on both of these. This 3 is going to come over, and it's going to be cubed. Okay, so what I really have is log base 7. Look, 9 squared is 81, so do it. So that's minus log base 7 x to the 5th power y to the 5th power plus log base 7 x to the 3rd power. Alright, so that's the first step. Second step, any term that's positive is going to contribute a factor to the numerator. Okay, so this term will contribute 81 to the numerator. Any term that is negative will contribute a factor to the denominator. Alright, so everything I just underlined in green is going to put a factor in the numerator because these are positive. Everything I just underlined in purple is going to contribute factors to the denominator. Okay, so that's why I'm going to have, alright, log base 7 of, okay, numerator 81 x to the 3rd power, denominator x to the 5th power y to the 5th power. Okay, now I can't leave it like this because it just so happened to have x's in the numerator and denominator, so I got to cancel these out. So these 3 x's are going to cancel out 3 of these x's, so that's going to leave 2 x's in the denominator. So the final answer is going to be log base 7 of, and in the numerator I'll just have 81, and this will be x squared y to the 5th. Alright, these 3 canceled out 3 of these and left 2 behind. Okay, so that would be your final answer for number 20. Alright, number 24. Alright, there are multiple ways to do this, but I'm going to go ahead and just distribute this 2. No, I don't want to do it that way. I could have done it that way. I'm going to go ahead and combine, condense these logs in the parentheses. So I'm going to go ahead and use my quotient rule. So this subtraction will become division, a over c. So that's going to make this 2 times the log base 6 of 15 over 5. Okay, so obviously that's 3. Okay, so now I've got 2 log base 6 of 3. Okay, so these coefficients are going to jump on over here. So that'll be 3 squared. This will be 25 to the 1/2 power. 25 to the 1/2 power, that's the same thing as square root. So this is going to be 5 in a second. Alright, how much space do I have over here? Not a lot. I'm running out of space, people. I'm running out of runway. So this is going to become log base 6 of 9. Alright, because the 2 came over, 3 squared. Plus log base 6 of 5. 25 to the 1/2 power. That's square root. So that's 5. And so I will do one last rule. This is addition now, so that's going to be my product rule. Alright, addition becomes multiplication when you condense. So this is going to be log base 6 of 9 times 5. And you can feel free to skip this step and go straight to log base 6 of 45. I'm just showing it because if I don't, I'm going to lose somebody. Don't want to lose somebody. Someone like you. Alright, so that's 24. 25. This is a long assignment. I hope I gave you time to start this in class, because doing this at home would be preposterous. Okay, this one will be easy by the Allen method. Alright, everything positive is going to contribute a factor to the numerator. And everything negative is going to contribute a factor to the denominator. So that's why we will have natural log of x, z. It's traditional to put the 3 in front. So 3xz from the green stuff, and then over y. The negative 1 goes in the bottom. Kabam! Thank you, Mr. Allen. Number 26. Okay, so yeah, I'm going to do the thing with the coefficients. So this is going to be 1/2 power. This is going to be squared. Remember, 1/2 power, that's really square root. So I'm going to have log of the square root of x plus 5 minus log x squared. Wait a minute. This says natural log. This has to be a typo. So let's go ahead and make this. Or maybe not. Let's not call it a typo. Let's assume that it is what it is. But because this is mixed in with LOGs, it does have to be a typo. They have to be the same base. So these are base 10. I can't have a base E in here. So this must be LOG. It must be log y. That was an error. In fact, it won't even be on your paper because I will have already fixed it. So there. Alright, so anyway, plus log y. Okay, so using the Allen method, everything that is positive is going to end up contributing a factor to the numerator. So that's this and this. Anything that's negative is going to contribute its factor to the denominator. So numerator, numerator, denominator. Okay, so that's why the final answer will be log see numerator, numerator. So I see that x square root of x plus 5. I need to multiply by y, but traditionally we would put that in front. And in the denominator, I will have x squared. So that will be the final answer for number 26. Alright, this may be another weird edit because I skipped this problem originally and I had to go back and do it. So I apologize for any weird edits that had happened. I'm going to go ahead and do the distributive property with this 3 across everything. So that's going to make this 3 natural log x minus 2 plus 6 natural log x plus 1 minus 3 natural log x plus 2 minus 15 natural log x minus 1. Alright, I just distributed this 3 everywhere. Okay, now all of these coefficients are going to pop over and become exponents. So that gives you this. Now I'm going to use a combination of the product rule and the quotient rule to clean this up. Alright, I've got addition and subtraction, but the way to think of it is every term here that is positive is going to contribute a factor to the numerator. Alright, so this is positive and this is positive. Now every term that's negative is going to contribute a factor to the denominator. So these two are going to wind up as factors in the denominator. Of course, I'm only going to write natural log once. Alright, I'm condensing. It'll be 1 log. But here I go. Alright, so numerator, numerator. So I will have x minus 2 to the 3rd power and x plus 1 to the 6th power. Now denominator, denominator. So I will have x plus 2 to the 3rd power and x minus 1 to the 15th power. And that is it. Alright, well this 2/3 is going to jump over here and become the 2/3 power. And this 3 is going to jump over here and become the 3rd power. Now as far as this x to the 2/3 power, let me do this off to the side real quick. Remember, when you have a fractional power, this right here is the power, and this right here is the root. It's power over root. So x to the 2/3 power is the same thing as the cube root of x squared. So that's what I'm going to do right here. So this is going to give me log base 2 cube root of x squared. Alright, log base 2 of y to the 3rd power. And then we just use that quotient rule, numerator, denominator. So this would be log base 2 of cube root of x squared over y to the 3rd power. That's it. Okay. Alright, man, we finally finished that little guy. So we're shifting gears over to here. This is that deal where we're given a couple of facts. And so we're going to plug them in and use them. So we're given 3 facts. So anything we see, we're going to try to rewrite it using either 4s, 5s, or 11s. 4s, 5s, or 11s are good. Okay? Because then we can just substitute. So this one, for example, what can we do? Well, 64 is 4 to the third power. Table. Memorize it. Alright, 4 to the third power. There's that 64. So that means I can write this as log base 3 of 4 to the third power. And using the power rule, I can put that 3 in the front if I want to. Alright, so this would be the same thing as 3 times the log base 3 of 4. Now, we know that's 1.26, so this will be 3 times 1.26. And using your 4-function calculator, 3 times 1.26, that is 3.78. Okay. Number 30. Remember, we want 4s, 5s, or 11s. Okay, I'm seeing a 4 in here and an 11 in here. Okay, because this is, well, I'll just rewrite it. So this would be the same thing as having log base 3 of, and this is, 4 squared, and this is 11 squared. 121 is 11 squared. You got to memorize that. Well, it's one of your multiplication facts. So now I could use the quotient property. All right, A over C is going to become subtraction. So this is going to be the same thing as having log base 3 of 4 squared minus log base 3 of 11 squared. Okay, these exponents, I could pop them to the front. Okay, so that would be the same thing as having 2 times the log base 3 of 4 minus 2 times the log base 3 of 11. Now both of these things we know the answer to. Alright, log base 3 of 4 is 1.26. So this is 2 times 1.26. And this is 2.18. Alright, using my 4-function calculator, so 2 times 1.26, that is 2.52. Alright, 2 times 2.18 is 4.36. And finally, 2.52 minus 4.36 is negative 1.84. So that will be the final answer to number 30. Alright, 0.25. 0.25 is 1/4. Okay, because this is 25 hundredths. It's 1/4. Okay, so this would be the same thing as having log base 3 of 1/4. Alright, well that's the same thing as having log base 3 of 4 to the negative 1 power. But I could use my power property to put this negative 1 in the front. So now we've got negative, alright, because the negative 1's in the front now. So negative log base 3 of 4. And once again, log base 3 of 4 is 1.26. So that gives us negative 1.26. So that's 31. Okay, 32. Remember, 4s, 5s, and 11s. That's what we want. Well, there's an 11 right there. And 20 is 4 times 5. So there's my 4, 5, and 11. So in fact, let me just go ahead and rewrite this. So this would be log base 3 of 11 over 4 times 5. Now I'm going to split this up using a combination of the product property and the quotient property. But I'm going to do it Allen style. Anything in the numerator will become a positive term. Anything in the denominator will become a negative term. So the 11 is positive, so I'm going to have log base 3 of 11. These two are both in the denominator, so they will both be minus. So minus log base 3 of 4 minus log base 3 5. All three of these we know the decimals for. Okay. Log base 3 of 4, that's the 1.26. So this is minus 1.26. Alright, let's see what else we had. Log base 3 of 5, that's 1.46. And log base 3 of 11, that was 2.18. Okay, it's putting these together. Even using a 4-function calculator, you can go 2.18 minus 1.26 minus 1.46. And that is negative 0.54. Alright, that's number 32. Number 33. 2.2. Goodness gracious. Alright. 2.2. Let me switch colors and do this off to the side. 2.2 is the same thing as 2 and 2/10. Alright, because this is the 10th place. Alright, this is 2 and 2/10. So this would reduce this fraction, so that's 2 and 1/5. Now I can turn this into an improper fraction by going 5 times 2 is 10 plus 1 is 11. So this is like 11/5. Okay, so 2.2 is the same thing as 11 over 5. Alright, if you've never seen that before, I mean, I know they taught it to us in elementary school, but that was like 1,000 years ago. So I don't know what they're teaching you kids these days. But I learned that if you have a mixed number like this, you can just multiply and add, 5 times 2 plus 1, 5 times 2 is 10 plus 1 is 11. Boom. Alright, but if you learned it a different way, you do what you need to do. Anyway, this becomes, wait, I want to go back to blue. This becomes log base 3 of 11 over 5. And then I can use my quotient rule and split it up as subtraction. So this would be log base 3 of 11 minus log base 3 of 5. And we're given both of these facts. Okay, log base 3 of 11, that was our 2.18. Log base 3 of 5, that's our 1.46. 4-function calculator, 2.18 minus 1.46. That is 0.72. This is a really long assignment. I'm going to try to let you start this in class because this is ridiculous. This is ridiculous. Okay, 100. Alright, let's see, I want 4s and 5s. I can do this. Alright, I'm looking at 100, and I'm thinking I want 4s and 5s. Alright, I know that 100 is 4 quarters. You know what I mean? 4 times 25. And I know that 25 is 5 squared. So I'll have eventually have 4 times 5 squared. So that's genius. So I have log base 3 of 4 times 5 squared. Okay. So using the product property, that's going to give me log base 3 of 4 plus log base 3 of 5 squared. Okay, now using the power property, this 2 is going to jump to the front. So I will have log base 3 of 4 plus 2 times log base 3 of 5. Okay, so that's going to give me 1.26, because that's a given fact, plus 2 times, alright, log base 3 of 5. I forgot what that was right now. 1.46. Alright, and I can do this in my for function well enough. Alright, so I've got 1.26 plus, alright, 2 times 1.46. That's 2.92 plus 1.26 is 4.18. So that would be the final answer for number 34. What? Why? Why are there more problems? I might have to cut this off, because why? I mean, why? Why? Yeah, I think we're done. We're done. I'm so over this assignment. Right. See, you know, guys, this is one benefit of having me make all these videos, because I have to do every assignment that I give you. I have to do. Man, I missed another problem. I missed number 27. I got to go back and do that. I missed like number 16 or something. Yeah, we're done, people. I missed 16 and I missed 27. I'm going to have to go back and do that. But yeah, let the record reflect. By the time you get your homework, this part here at the bottom, it'll be cut off. So yeah, there's that. 40 I mean, come on, who created this thing? And why? We've already got a section of this. It's done. Peace out, people. I'm over it. This video is over an hour long. It's ridiculous. And I got to go back and edit. You know what? It's almost 1 a.m. now. Do you realize that? It's 12:54 on Sunday morning. You know, a.m. It's crazy. I'm just losing it. Peace.